Hey everyone, I thought we could look at the review stations today. There are 12 of them, and so let's start. I guess this is 55 stations. Not that there are stations to the number of 55, but instead assignment 55 review stations. Okay, so a bunch of them are just taking derivatives. So let's see how that goes. Find the derivative of each function. 1 f equals x square root 2x plus 1. Well, I think this is much easier to do if I use the rational exponents. And I have to see this as a product rule. So f prime is going to be this times the derivative of that times the derivative of that inside function plus this times the derivative of that. Okay, and I do think I'm going to tidy this up because we are getting very close to chapter 5. We're only going to be setting derivatives equal to 0. So what I see is this 2 and that 2 will cancel. And then I see these both have a 2x plus 1, so I take out the smaller power. And what's left over is this x, this plus sign, and I factored a negative 1/2, so I've got a 2x plus 1. That's going to be 3x plus 1. And for you old school people, square root 2x plus 1. But really, the old school people would say rationalize the denominator. And where does the madness stop? So I say stop here or tidy this up to 3x plus 1 and stop. Because really, in chapter 5, we're going to be setting a derivative equal to 0, and so we want this factored form. The negative exponent is simply telling me that this is going to be when the derivative is undefined, and this is going to be when the derivative equals 0. And both of those will be stuff we're interested in going forward. All right, so second problem. Actually, station 1 has 3 problems. So second problem, f of x equals ln square root of x. You might want to write that as ln x to the 1/2. You may even want to bring that down out in front. 1/2 ln of x. And so then f prime would be 1/2 times 1 over x. Or let's imagine I didn't see to use that power rule. Instead, I said f prime was the derivative of ln of stuff, which is 1 over stuff, times the derivative of stuff, 1/2 x to the minus 1/2. So that's the same as looking at 1 over square root of x times 1 over 2 square root of x. Look, square root of x times square root of x is going to be x, and there's also a 2 down there, okay? And that's the same as 1 over 2 times 1 over x like we got the other one. I don't care which of those ways you take, I just want you to be comfortable taking that derivative. All right, f of x equals x e to the minus x. So it's a product rule. F prime equals 1 times e to the minus x plus x times e to the minus x times negative 1. So again, that was this times the derivative of this plus this times the derivative of this. The derivative of e to the is e to the. Don't forget to take the derivative of the inside function. So that was station 1. Station 2 also has 3 derivatives on it. And it starts off with 1 is y equals ln of sine of 2x. So please take that derivative. Come back when you're done. Hey, welcome back. So y prime, derivative of ln of stuff is 1 over stuff times the derivative of stuff. Well, the derivative of sine is cosine, leave the inside alone, times the derivative of that innermost 2x function, which is 2. So I guess you could write this as 2 cotangent 2x if you were going for the Titan thing. You could also leave it here on free response. There's question 1 on station 2. Question 2 because nobody forgets how to take the derivative of logs. Yeah, everybody does. So then y prime equals 1 over x squared ln of the base times the derivative of the inside. And again, maybe this is easier to see if you rewrite it with the change of base formula. X squared over ln of 2. And so my suggestion before, when we were talking about this the first time, was to say I would think it would be much easier on the brain, x squared, to think about the problem this way. This is what y is equal to. This is a constant times a function. I'm going to take the derivative of the function, and I'm going to multiply by this constant. The derivative of this function, ln of stuff, is 1 over stuff times the derivative of stuff. And here we have 1 over ln of 2. These can cancel, and so I end up with 2 over x ln 2. There we go. Okay? If it's not okay, you should definitely be asking questions, or go back to the video for derivative of logs and exponentials and practice some more of those problems. Okay, problem number 3, y equals e to the tangent inverse of x. Okay, so this is e to the, and we know the derivative of e to the is e to the times the derivative of that inside function, which is 1 over x squared plus 1. Now, you really can't forget these. I meant it when I said it. It's only been a couple of days and you've already forgotten that. No, it's not okay. Please know your derivatives. Maybe you want to make some flashcards. That was station 2. Station 3. Station 3 is 4 derivatives. Ooh. Number 1 says f of x equals x to the 1 plus root 2. All right. Come back when you're done. Find me your derivative. Well, I hope you saw this as x raised to a number. And so the power rule is appropriate here. So I'm going to have 1 plus root 2 times x. What am I supposed to do with the power rule? If it's x to the third, I bring down the 3 and subtract 1. So I need to subtract 1 from this, which gives me that. Here's my answer. It's just the power rule. Don't be scared of that. When you use the power rule, you just subtract 1. Okay, second problem on this station was f of x equals 8 to the x. And I, of course, want f prime. I would love to be able to say 5, 4, 3, 2, 1 now, but I think that some of you might need a little more time. And if you need a little more time on taking that derivative, it suggests that you need more practice. Have I mentioned the value of flashcards? 8 to the x, ln of 8. Of course, don't forget derivative up here, if there's any, but for us, that would just be 1. Okay, those are the first 2 stations. I'm sorry, the first 2 problems on station 3. For number 3, we've got f of x equals log of square root x plus 1. So f prime is going to be what? Well, remember, log is log base 10. So we're going to have 1 over ln of 10 times square root x plus 1. Why? Well, remember what we're really looking at here is ln of square root x plus 1 over ln of 10. So there's that ln of 10. And then the derivative of this, ln of stuff, is 1 over stuff. Here's my 1 over stuff. Times, don't forget the derivative of stuff. A lot of people actually forget this part, times 1. I'm not sure why they forget this part. And yes, Nathan's right. We can flip this down into the denominator, and this square root times this square root will be canceling. And so I guess I could tidy this up as 1 over 2 ln of 10 times this times that is just going to be x plus 1. But I'm putting this x plus 1 in parentheses because this stuff would need to be distributed to each of those. Okay? All right. And that was number 3. Let's take a look at the fourth problem on station 3. The fourth problem says f of x equals secant inverse 2x plus 1. Okay, so then f prime, remember, inverse secant's derivative, 1 over absolute 2x plus 1 square root 2x plus 1 squared minus 1. Not quite done. Don't forget the derivative of stuff. To tidy or not to tidy, well, that one and that one will be able to cancel. So maybe it's worth it. I can't cancel out those 2's because that doesn't have a 2. Maybe I'll get a 2 coming out from here that could cancel with that 2. Yeah, let's see. 2 over 2x plus 1 square root 4x squared plus 4x plus 1 minus 1. Yeah, so those go away. And then here, I can rewrite this as 2 absolute 2x plus 1 square root. I'm pulling out that 4. I know I could pull out an x as well, but it's not going to be an x squared, so it's not going to be able to come out. So I'm just going to leave like this. Because this thing, square root of 4, is a 2. So I'm going to pull that 2 out, and then those can cancel. So I end up with 1 over 2x plus 1 square root x squared plus x. All right. Station 4. Station 4 has one function on it and 3 questions, and you'll never guess which one this is. Station 4. F of x equals x to the 5th plus 2x to the 3rd plus x minus 1. Find, 1 says find f of 1 and f prime of 1. Well, f of 1, we're just plugging the 1 in for all those x's. So 1 plus 2 is 3, plus 1 is 4, minus 1 is 3. Excellent. And now f prime of 1. Well, so I kind of need f prime of x to find that out. So I'm going to take the derivative here, 5x to the 4th. I'm going to take the derivative here, 6x squared, and the derivative here is 1. And now when I do f prime of 1, I get 5 plus 6 plus 1, or 12. So on f, I see the ordered pair 1, 3, and the slope at 1 is 12. So if I wanted to write a tangent line equation, it'd have all the information I need. Slope at a point and a point. But part B says this. Part B says, I guess that was A. And so B says, find f inverse of 3. And then it says, find f inverse prime of 3. Okay, so what's that going to be? Well, remember, there's a function. There's the inverse of that f function. To make an inverse, we switch the inputs and outputs. So 3 becomes the input, and 1 becomes our output. Okay, that's all that is. It's just switching the x's and y's. It's understanding notation. It's remembering that when we want to make the inverse of f, and f has a point 1, 3 on the graph, there must be a point on f inverse called 3, 1. Now, what about the derivative on the inverse at the inverse point? Well, just like we switched x's and y's here, and we knew that slope here was a change in y's over a change in x's, since we switched the x's and y's for the inverse function, we're now going to have not y over x, but x over y. And what that really means for us is our derivative, our slope at the inverse point on the inverse function is going to be not y's over x's, but x's over y's. So the reciprocal of the slope at the original point on the original function. If the slope at the original point on the original function is 12, then the slope on the inverse function at the inverse point, 3, 1, is going to be the reciprocal. Okay? This is now the third time we've talked about this. You really need to own this. So, f of 1, I plugged the 1 in there. F prime of 1, I had to find the derivative of f first and then plug in a 1. F inverse of 3, it's never not going to be that, because we don't know any other things about f besides that. Okay, be pragmatic. And then f inverse prime is the reciprocal of f prime of 1. F inverse prime of 3, i.e. on the inverse function at the inverse point, the slope will be the reciprocal of the slope of the function at the original point. Okay, so at the original point, this is the slope. At the inverse point, we have our reciprocal slope. All right. And part C here said, write the equation of the line tangent to f when x equals 1. Oh, look at that. I did need that point. So we need this, and we know that f prime of 1 was 12. So then y minus 3 equals 12, x minus 1, and move along. That was station 4. Station 5. Station 5. Ooh, there's some implicit differentiation here. Let's see. This one comes with 3 derivatives, and the directions say find dy dx in each case. Okay. So what's the first one? First one is x squared y plus xy squared equals 6. Please note that these are products, so you have to use the product rule here and the product rule here. That's just a number. Derivative of the number is 0. So let's get along with our product rule. You might want to pause the video and give it a try yourself. So this times the derivative of that with respect to x, derivative of that with respect to x, plus that times the derivative of x squared. Plus, now we're over here, this times the derivative of that. Remember, the derivative here is that, right? I'm using the power rule. But now I have to come back and take the derivative of y with respect to x. Plus, we did this times the derivative of that. Now we need y squared times the derivative of that. Y squared times 1. And all of that equals the derivative of 6, which is 0. Remember, we're not done yet here until we have dy dx by itself. So I'm going to move some not dy dx stuff to the other side. And I'm going to leave all the dy dx stuff here, but I'm going to factor out the dy dx. So I'm going to have dy dx times x squared plus 2xy. And then that equals this move to the other side, minus 2xy. This move to the other side, minus y squared. Not done until dy dx is by itself, so I need to divide. And so my answer is going to be, and don't box in your answers, it's about habit, is going to be this. Ooh, I can take out a y and a y and a y, but not over here. I can take out an x and x and x, but not over here. So just leave it. Okay, that's the first question. And how about the second one? Well, the second one is y equals the sine 5/4 of x plus 5. Okay, now, of course, we could write that as sine of x plus 5 raised to the 5/4 power. And I think my evidence shows that students make fewer mistakes when they rewrite it so that it looks like this, rather than take this on here. I'm not saying don't do that. I'm just saying students tend to make fewer mistakes when they do this, because this gives their brain time to slow down a little bit and realize that they're starting with the power rule for y prime, 5/4, leave the inside alone. And it's that these students are more likely to remember subtract 1, right? We brought down the power, we have to subtract 1. The students who do this often forget that. times the derivative of sine, leave that inside stuff alone, times the derivative of the innermost x plus 5, which is just 1. All right, that was the second problem. And the third problem is x plus sine y equals xy. Okay, so again, we're looking for dy dx, which means we're not going to be done until we have dy dx by itself. So let's take the derivative here. Derivative of x is 1. The derivative of sine is cosine, leave the inside alone, but then come back and take the derivative of that inside stuff with respect to x. Over here, I've got a product. So over here, I need to use the product rule. 1 times y plus x times dy dx. So I want to get all the dy dx stuff to one side, and the stuff that's not dy dx, I'm going to move to the other side. So I'm going to have cosine y dy dx minus x dy dx, because I moved this over, equals y minus 1. This one. Factor out that dy dx. And you get cosine y minus x equals y minus 1. And now divide both sides by cosine y minus x. Cosine y minus x. Okay. These will cancel, and I'll see that dy dx equals this. Okay, that was station 5. Station 6. Ooh, this one comes with a table. The table here says f and f inverse, 0 and 1. We've got 9, -2, and -3, and 1/5. So, use the table to the right to find the first derivative at the given point. So, I'm told in part A that y is equal to f of x times square root of x, and I want to know the derivative at x equals 1. Okay, so I got to take the derivative of this. This is a product, so I'm going to use the product rule. This times the derivative of that, plus this times the derivative of that. And we want to know y prime of 1. So that's f of 1 times 1 over 2 square root of 1 plus square root of 1 times f prime of 1. Okay, so f of 1 is -3 over, that's just going to be 2 plus sine square root of 1 is 1. F prime of 1 is 1/5. Yeah, I'd probably make the common denominator, but if this is for your response, stop here. Save yourself the suffering. So I'm going to have -15 plus 2 over 10, which is -13 over 10. That's y prime of 1. Okay, y prime of 1, we're good to go. That was our first one. We've got 2 more here on the page to do. On the station. Part B says that y equals the square root of f of x, and this time we want to know the derivative of x equals 0. So again, I think writing this like this is helpful. I think students are more likely to remember to subtract 1 from its numerator. So y prime is 1/2. Leave the inside alone, subtract 1 times the derivative of the inside function. And if we want y prime of 1, we've got to plug a 1 in for f. So we've got 1 over 2 square root of f of 1 times f prime of 1. Well, f of 1 is -3. And that sucks. I guess that tells me the derivative doesn't exist. F of 1. Did I really want that at 1? Oh, no, I wanted it at 0. I'm such a noob sometimes. Alright, let's change these to 0. Now, I need f of 0. Oh, how convenient. F of 0 is something I can take the square root of. So square root of 9 is 3. 1 over 2 times 3, or 1 over 6. F prime of 0? F prime of 0 is -2. So I have -2 over 6, or -1/3 for y prime of watch out for little mistakes. And then the third one, we're back to derivative of x equals 1, and this time we have y equals f of square root of x. So I'm using the chain rule here, derivative of the outside function, leave the inside alone, times the derivative of the square root of x, which looks like that. Now, if you're not comfortable seeing this and saying that's its derivative, it may be helpful to say, okay, square root of x equals x to the 1/2. And then you're using the power rule. You're bringing down the 1/2, and you're subtracting 1. All right, so what are we looking for? Derivative at 1. We need y prime of 1, which is going to be f prime at the square root of 1 times 1 over 2 square root of 1. Okay, well, square root of 1 is 1, so this is just f prime of 1 times 1/2. F prime of 1 is 1/5 times 1/2, not plus, but times. And so we get 1/10. Okey-doke. That was station 6. Station 7. Station 7 says that g of 2 equals 3, and g prime of 2 equals -4, and we're asked to find, I know, this is just like something regarding g. Yeah. Now we want to find f prime of 2. There's no f's, Mr. Cooper. So here, part A says f of x equals x squared minus 4 times g of x. So here's our f of x, and we want f prime of 2. Please start by finding f prime of x. Don't try and shove the 2 in simultaneously as you take the derivative. Those people almost always make a mistake because they're trying to do too much at once. So just start with the derivative. Oh, also, by the way, sometimes problems like this show up on the AP exam, and they explicitly ask for f prime of x and f prime of 2. And students, because they're trying to cram too much in at once, forget that the question is explicitly asking to see the presence of f prime of x, and they only have the correct f prime of 2. Now, they must have had the correct f prime of x in order to get f prime of 2, but guess what? If they asked you for f prime of x and you don't give it to them, you just lost that point, right? So, show f prime of x. It's a good habit to be in. Derivative of x squared is 2x. This is a constant times a function. The derivative of a constant times a function is going to be a constant times the derivative of that function. So that's my f prime of x. I want f prime of 2. So that's 2 times 2, right? Because x equals 2, so I put the 2. Minus 4 times g prime of 2. G prime of 2 is -4. I mean, 4 minus 4 times -4. -4 times -4 is positive 16, plus 4 is 20. I don't believe how many people come up with 0 for this. Yeah, slow the brain down. Okay, so that's not plus, that's not. F prime of 2 is 1. Excellent. By the way, this station has F parts to it. So let's go move on. 3 and g prime of 2 equals -4. And in each case, we're looking for f prime of 2. So in part B, we're told that f equals x over g of x. So quotient rule, f prime is going to be low, d high, minus high, d low, the derivative of g is called g prime, all over low squared. And of course, we want f prime of 2, so that's going to be g of 2 times 1 minus, what's x? X is 2 here, right? We want f prime of 2, so plug 2 in for all the x's, times g prime of 2 over g of 2 squared. So g of 2 is 3, and g prime of 2 is -4. -4 times -2 is positive 8 over g of 2 is still 3. 3 squared is 9. And so I end up with f prime of 2 equals 11 over 9. Part B, I get 11 over 9. What about part C? Okay, so part C says f of x in this case equals x squared times g of x. Nice. Again, we want f prime of x. This is a product, so I'll use the product rule. 2x times g of x plus x squared times g prime of x. And we want f prime of 2. And so that's going to be 2 times 2 times g, and 2 plus 2 squared times g prime of g. G of 2 is 3. 3 times 4 is 12, plus g prime of 2 is negative 4. Negative 4 times 4 is negative 16. And so we end up with negative 4. And prime of 2 equals negative 4. All right, that was part C. How about part D? F this time is equal to g squared of x. Okay, remember, that's the same as g of x squared. So when I come to make f prime, I see power rule and something on the inside. So 2, leave the inside alone, times the derivative of the inside, like that. So f prime of 2 then is going to be 2 times g of 2 times g prime of 2, or 2 times 3 times negative 4, which is negative 24 for f prime of 2. It would be really fabulous if you were as comfortable with this as you see me being. That comfort allows you to go a little faster to save time for when you really need it. Okay, part E says that f of x equals x times the sine of g of x. Okay, so again, let's start by finding f prime. And so I see a product rule. So I'm going to have 1 times the sine of g of x. The derivative of this times this, plus this times the derivative of this. The derivative of sine is cosine times the derivative of that inside function, g prime. Okay, no, I can't take that out because they're trapped inside of those trig functions. F prime of 2, though, I can figure out. That's sine of g of 2 plus 2. That's an x value. That's our x value. So gotta plug a 2 in there. Cosine g of 2 times g prime of 2. Now, g of 2 is 3. And that's going to be sine of 3 plus 2 cosine of g of 2 is still 3 times g prime of 2 is negative 4. And I would say you can stop here. If this is a calculator portion, make sure your calculator is set in radians. But I'm going to stop here, except maybe I'm going to take that. So I'm going to have sine of 3 minus 8 cosine of 3. That's okay if it's not a calculator. If it's calculator, yeah, we definitely have to take it. So then the last problem on station 7, we're told that f of x this time is x squared ln of g of x. Yeah, no kidding. It's a product rule. So what are you going to get for f prime of x? Did you get 2x ln of g of x, right, derivative of this, times that, plus that, times the derivative of this? Well, the derivative of ln of stuff is 1 over stuff times the derivative of stuff. Therefore, f prime of 2 is going to be, don't forget to plug the 2 in here and in here. 2 times 2 is 4, ln of g of 2, plus sine. 2 squared is 4, g prime of 2 over g of 2. So we know that g of 2 is equal to 3. So the derivative then of prime of 2 is going to be 4 ln of 3 plus 4. G prime of 2 is negative 4. Negative 4 times positive 4 is going to be negative 16 over g of 2 is 3. And I would just stop there and move on. If you really need to make a common denominator, then that's going to be 12 ln of 3 minus 16 over 3. And then, yes, you could factor a 4 out of each of those if you really, really needed to, but I'm not going to support such madness. Well, until we really need to do it. That was station 7. Let's take a look at station 8. Station 8 says that the position of a particle is given by position of a particle, S of t, is given by 10 cosine t plus pi over 4 for t seconds after starting t greater than or equal to 0. Okay, so, if I were thinking about graphing this, my graph would start high at negative pi over 4, and then at pi over 4 would be at 0, and at 3 pi over 4 would be at negative 10. And so we're talking about something that looks like this, except we're starting at 0. So just a frame of reference. This is my function. What is the particle's initial position? Well, initial position means position at time equal to 0. So I want to know S of 0. 10 cosine 0 plus pi over 4 is 10 cosine pi over 4. Cosine of pi over 4 is root 2 over 2. See, look, you've got to know that the cosine of pi over 4 is root 2 over 2. That's why we banged at that stuff so much in January, because we needed to just be able to say, oh yeah, cosine of pi over 4 is root 2 over 2. We really do need all those basic unit circle values memorized. And so I get 5 root 2. So where is the particle? The particle is at this place called 5 root 2. Don't worry, all the cool kids go there at t equals 0. Okay. What points reached by the particle are furthest to the left and furthest to the right of the origin? Well, remember that graph I drew a few moments ago? Okay, so we started over here at negative pi over 4. This is y equals 0, or s equals 0, and that's an amplitude of 10. So this is 10. And then we went down here, and this was 3 pi over 4, negative 10. And then we came back up. So notice that this 10 is going to be also over here, 10. And this is going to be 5 pi over 4. So what can we say about furthest left and furthest right of the origin? Well, this is really important. This is time. This is position. The origin is a position. The origin is 0. Now that doesn't mean I'm looking for this. Actually, maybe it doesn't. Furthest to the, no. This thing is the origin. Why is that thing the origin? That thing is the origin because the s value at any point on this line, s equals 0. This is position. So position should be equal to 0 if we're at the origin. Anytime we're touching this line with this position function, we're considered to be at the origin. Remember, this point was 5 over, was it 5 over root 2? Root 2 over 2, no, it was 5 root 2. So at time 0, this is my position. When am I at the origin? When I'm here. This is me being at the origin. This is me being at the origin a second time. Why? Because this line, even though it's labeled as the t-axis, has an s value of 0. This is s. This is s being positive. This is s being negative. This is s being 0. Not just here. Anywhere on that line. Okay? So furthest to the left, furthest to the right. Okay? Because these are position values. All right. You may want to think about this one again in a few minutes. C. When does the object first reach the origin? And what is the velocity, acceleration, and speed at that time? Okay. to that graph. Boy, sure am glad I know how to graph these things. And you know, maybe we should go through the graphing of this thing. Okay, so we set t plus pi over 4 equal to 0, and t plus pi over 4 equal to 2 pi. And so I know that t equals negative pi over 4, and over here this is 8 pi over 4 minus 1 pi over 4, and I get 7 pi over 4. So my graph, positive cosine, looks like this. This is negative pi over 4. This is positive pi, 7 pi over 4. This down here would be halfway in between, 3 pi over 4. My quarter points at pi over 4 and 5 pi over 4. We don't have any d value, so we know that the midline is running right through that place in the graph where s equals 0. And I thought we had that. Yes, at 0, we've got 5. Okay, 10 and negative 10 and positive 10. So what are we looking for? When does the object first reach the origin? Well, we just said that the origin is this line. It's not just that point. It's this line because position equals 0 every time we're touching that line. And the first time that happens is at pi over 4. When does the object first reach the origin? The object first reaches the origin at pi over 4. So, the object first reaches the origin at t equals pi over 4. See, I gotta write the sentence. Don't just write pi over 4. All right, next, what are the velocity, acceleration, and speed at that time? Well, if this is s of t, and we know that v of t is also s prime of t, we just need to take the derivative of this. It's going to be 10 times the derivative of cosine is minus sine, so really it's going to be negative 10 sine leave the inside alone, times the derivative of the inside, which is 1. So now we want v of pi over 4, negative 10 sine pi over 4 plus pi over 4. Pi over 4 plus pi over 4 is pi over 2. Sine of pi over 2 is 1. 1 times negative 10 is negative 10. The next thing we're asked for is acceleration, but I want to actually jump ahead to speed at t equals pi over 4. Why? Because remember, speed is the absolute value of velocity. So speed at is 10. If velocity was negative 10, and speed is the absolute value of velocity, the absolute value of this is that. Okay, now, what about acceleration? Well, we know some things about acceleration. We know that a of t is v prime of t, or s double prime of t. So this is s prime. I want to take the derivative of this. So I'm going to have negative 10. The derivative of sine is cosine, times the derivative of t is 1. And I want to evaluate a of t at pi over 4. So that's going to be negative 10 cosine pi over 4 plus pi over 4 times 1. That's going to be pi over 2. Cosine of pi over 2 is 0. Negative 10 is 0. Okie doke. That was station 8. And the little wireless mouse doesn't work. Is it still work? Yes, it still works. Thank you, little wireless mouse. Okay, station 9. Station 9 says find dy dx in each case. Okay, 1, y equals tangent inverse 3x squared plus 2x. Okay, chain rule. Give it a try. Come back. Y prime is 1 over stuff squared plus 1. times the derivative of stuff. Yeah, I'm not going to put it. No, move on. 2. Y equals e to the tangent of sine of x. It's not tangent times sine of x, it's tangent of sine of x. Okay, what happens here? Sure, y prime, e to the stuff's derivative is e to the stuff times the derivative of stuff. I mean, really, it's times ln of the base. But ln of the base is going to be 1. Don't forget it when this problem says 2 to the tangent of sine x. Right? This one's derivative is going to be this times ln 2 times the derivative of that stuff. Please don't forget that when you have something that's not e. So the derivative up here, the derivative of tangent is secant squared, that inside alone, times the derivative of the inverse function, and then we stop. Okay? So the derivative of e to the is e to the times the derivative of tangent of stuff times the derivative of stuff. Okay? And number 3. This one says y equals secant inverse 1 over x. Yes, you can use the quotient rule here, but I don't want to. Though, if I don't want to, be careful, because this is a power, and that's the inverse. And so maybe you just want to leave it like that for now. Y prime, well, that's 1 over absolute value, 1 over x, square root 1 over x squared minus 1. That's the derivative of inverse secant of stuff times the derivative of stuff. So now that's x to the negative 1. And so that's the derivative of x to the negative 1. I can imagine that if you saw this on multiple choice, this would not be the answer. But in fact, we would have some sort of simplification of this expression. So I know you don't want to, but I'm actually going to go through it because, we really should. Okay? So what's going to happen here? Well, this is the same as negative 1 over x squared. And notice here, I've got a negative 1 on top, 1 times negative 1. Now on the bottom, I have this 1 over x. I have this square root of 1 over x squared minus 1. And I have 1 over x squared. So this x squared is on the same level as this one. Okay. Next, I'm going to make a common denominator here. So that's going to be x squared over x squared. So I can write what's under here as 1 minus x squared over the common denominator. Now I'm going to split this radical into 2 radicals. So why am I doing that? Well, square root of x squared is absolute value of x. Absolute value of x times x. Absolute value of x times absolute value of x. I'm going to get x squared. So this and this become 1 over x squared. Now notice, this is above this one, so these can cancel. And so I'm left with, what am I left with here? I'm left with dy dx equals negative 1 square root 1 minus x squared. So I recognize this derivative as the derivative of inverse cosine. Okay? Derivative of inverse cosine is what I'm looking at here. So this thing that we started off with, secant inverse 1 over x, that's the same as inverse cosine of x. Okay? And we run into that before. I don't expect you to memorize that, but that explains why the answer looks the way it does. Okay? All right, station 10. Station 10 is another table problem. And we've got f and g and f prime and g. We have some x values here. and that's 2, 8, 3, 1/3, -3, 3, 3, -4, 2 pi, and 5. All right, so we've got all that information. Let's go. And it looks like I have 6 derivatives here on station 10 that require me to use this table. So we start off with f of x times g of x at x equals 2. So I'm looking for the derivative of this at 2. Well, that's product rule. You should be comfortable with that. F of x times g prime of x plus g of x times f prime of x. And we want to know this derivative at 2. So I want to know f of 2 times g prime of 2 plus g of 2 times f prime of 2. And I know that many of you are going to do this in your head and skip this step here. But really, I do this because I've been doing this for a long time, and I know I make fewer mistakes when I do this. So you do you, but I'm going to be doing this. So f of 2 is 8, g prime of 2 is -3, plus g of 2 is 3, times f prime of 2 is 1/3. Well, 1/3 times 3 is 1, so we have -24 plus 1, which is -3. This is our derivative at x equals 2. Okay, let's move on to d. And d is f of x over g of x at x equals 3. Okay, well, this is pretty clearly quotient rule. So my derivative will be low d high minus I d low all over low squared. A lot of people forget this. Watch out for that. So we want derivative of 3. So I need g of 3 times f prime of 3 minus f of 3 times g prime of 3 all over g of 3 squared. So g of 3 is -4. F prime of 3 is 2 pi minus f of 3, which is 3, g prime of 3, which is 5, all over g of 3, -4 squared. So I end up with -8 pi minus 15 over 16. Okay? What's next? Part E. E says f of g of x at x equals 3. So this is chain rule, right? Because one function is eaten another function. Whenever we see composition, we know we're looking at chain rule. And so my derivative of the outside, leave the inside alone, times the derivative of the outside. We want f prime of g of 3 times g prime of 3. Well, g of 3 is -4. Son of a bitch. I thought I had fixed all those problems. Grrr. Does it work with g of 2? Maybe I want 2. Let's see if that fixes it. G of 2 is 3. F prime of 3, yes. So that has to be fixed. That's at 3. Okay, I'll get that fixed by the time you look at the stations. This won't be there anymore. So we want, yeah, it did say 2. I wrote down 3. Oh, so dyslexic. Okay, so 2 and 2. And the reason it said 2 was because this problem isn't going to work with the 3. G of 2 is 3. So we want f prime of 3 times g prime of 2. G prime of 2 is -3. F prime of 3? F prime of 3 is 2 pi. So we get 2 pi times -3, or -6 pi. There's my derivative. Okay. Next, f says square root of f of x at x equals 3. I hope it works. All right, so remember that this is the same as f of x raised to the 1/2 power. So when I take the derivative here of 1/2, leave the inside alone. Don't forget to subtract 1 times f prime of x. But we want to know the derivative at 3. So we're going to do 1 over 2, 1 over square root of f of 3 times f prime of 3. Okay, so f of 3 is 3. So we're going to have 1 over 2 root 3. F prime of 3 is 2 pi. I guess these 2's cancel. And so I'm looking at pi over root 3, which is fine by me because I don't use a slide rule, but you could always rationalize and have that one. Okay? My bet actually would be this would be the multiple choice answer, and you wouldn't see that. Cool. There's F. 2 more on station 10. Let's take a look at G. G says 1 over g squared of x at x equals 2. Well, so I know that this is the same as 1 over g of x squared. And yeah, I really think I want to just write that as g to the negative 2. So that when I take the derivative, hey, if you now do this, this is a linkage error because this is the original and this is the derivative of the original. And those things are not equal to each other. So don't do that. Instead, now take the derivative. Minus 2 g of x to the negative, subtract 1, 3, times the derivative of g, times the derivative of that inside function. You know, you're welcome to use quotient rule here. I just find this one a little easier to do this way. We want to know the derivative at 2, so I'm going to have negative 2. Just don't have any in there. Let's get rid of this stuff. Okay, so I've got negative 2 over g of 2 to the third times g prime of 2. So g of 2 is 3. 3 to the third is 27. And g prime of 2 is negative 3. So I end up with 2 that's positive because negative times negative is positive. Okay, and then the last one on station 10. Yeah, I understand why College Board loves these table problems because with the table problem we're really focused on the fundamentals of being able to take derivatives of all kinds of things like square root of f squared x plus g squared x at x equals 3. You know, if this was sine squared plus cosine squared, that would be 1, and the square root of 1 is 1. And then when we take the derivative of 1, we get 0. But this isn't sine squared, and that's not cosine squared. So instead, we're going to have to take the derivative in a little more cumbersome manner. Take the derivative of the outside. I leave the inside alone. Don't forget to subtract 1. Times the derivative of the inside. Well, remember, f squared of x is the same as f of x squared. So this is chain rule again. So I bring down the 2 times f of x. I left that inside function alone. Times the derivative of that inside function. But wait. We now have a plus sign. And now we have to take the derivative of this, which is going to be 2 times g of x times g prime of x. Okay, right? Because derivative of the outside, I bring that down, leave the inside alone, take the derivative of the inside. And the same thing happens with g squared. Bring the 2 down, leave the inside alone, take the derivative of the inside. All right, but we want to evaluate this at x equals 3. Okay, so I want f of 3 squared. I want g of 3 squared. I want f of 3 times f prime of 3. F of 3 times f prime of 3. Plus g of 3 times g prime of 3. G of 3 times g prime of 3. Don't lose that 2. So negative 20 times 2 is negative 3. All right, now what about this? Well, this is going to be 25. And this is 1 over the square root of 25. Right? So intermediate step, square root of 25. No. 1 over square root of 25 times 1 half. Well, that's 5 times 2 is 10. And so I can rewrite this as 12 pi minus 40 over 10. And sure, I could take a 2 out of all of those. Negative, positive 6 pi minus 20 over 5. And I would probably stop there. Okey-doke. So that is exactly what I got last time. That's station 10. Station 11. Use the limit definition of the derivative to determine f prime of x equals 1 over x. Limit definition of the derivative. No, Mr. Kukla, that was so long ago. You said we would never. Yeah, I didn't say that at all. I said you have to. You have to always know how to do this. So we're looking for f prime of x. That's the general derivative. And so I'm going to use the fact that f prime of x equals the limit as h heads to 0 of f of x plus h minus f of x all over h. Why am I using this limit definition of the derivative? Because I'm looking for the general derivative, not the derivative of a point. Remember, f of x plus h means I plug an x plus h in for all the x's of f of x. So this then becomes, in fact, I think I really like that habit, the limit as h heads to 0 of 1 over x plus h minus 1 over x all over h. So up here in the numerator, I got to make a common denominator. I'm going to multiply by x over x here, and here I'm going to multiply by x plus h over x plus h. So the next line of this will be f prime equals the limit as h heads to 0 of x minus x plus h over x plus h all over h over 1. So here's a complex fraction. Instead of dealing with this complex fraction, I'm just going to do the flip and multiply now. Okay. Don't forget to distribute that negative to that h. And so where does that take us? Well, that takes us to, trying to get rid of some visual noise. Okay, that takes me to the limit as h heads to 0 of x minus x. They cancel. I just have a negative h, x plus h times 1 over h. Behold, and now I want the limit as h heads to 0 of negative 1 over x plus h. And at this point, it's now safe to plug that 0 in for h, and I get negative 1 over x squared. Use the limit definition of the derivative to find f prime of x. That's f prime of x. And you knew that because this is x to the minus 1. And if you use your shortcut, you bring down the negative 1 and subtract 1 there. There's that negative 1 on top. And x to the minus 2 is 1 over x squared. Okay, that was station 11. Station 12. Our last station for today. Station 12 says, explain why f of x does not have a derivative at x equals 1, given f of x is this piecewise function. Okay, so let's think about what we need. Remember, we need the limit as x heads to 1 from the positive side of f prime to equal the limit as x approaches 1 from the negative side of f prime. We want the limit of the slopes to be the same. So let's check to see if the limit of the slopes are the same. Okay, so I'm going to need the slope from this side. F prime is going to be 2x for x less than 1, and the derivative here is 2x greater than 1. And so what can we say? Well, the limit as x approaches 1 from the negative side of f prime is plug in a 1 there. 1 times 2 is 2. And the limit as x approaches 1 from the positive side of the slopes, talking about slopes, as we approach 1 from the other side, we get 2. So I see the limit of the slopes as being the same from both sides. So I know that's good. Hey, by the way, see how I used shortcuts to get here? If they ask you to use the limit definitions or one-sided derivatives, be prepared for that. I don't think that's likely, but yeah, it could happen. So this was one of our prerequisites for differentiability, that we could in fact know that the limit of the slopes from both sides of that point on f were the same. But there was a second requirement for differentiability. Remember, f must be continuous at x equals 1. Is f continuous at x equals 1? If I plug a 1 in here, so this is the limit as x approaches 1 from the negative side of f. I plug a 1 in there, I get 1 squared or 1. And now the limit as x approaches 1 from the positive side of f, that means I plug a 1 in here, which is going to be 1 times 2 or 2. Behold, the limit as x approaches 1 from one side does not equal the limit as x approaches 1 from the other side, and therefore this function is not continuous at x equals 1. I have a jump discontinuity there. So no, this function does not have a derivative because f is not continuous. Now, some of you are saying, Mr. Kuko, I checked continuity first and noticed that the function wasn't continuous. Great. Stop there. I didn't want to assume that you were going to check continuity first. I think it's good to check continuity first. It's often easier. But you do need to check both. Like if it turned out the function was continuous at 1, then I would definitely need to check to see that the limit of the slopes of f, not f, but the limit of the slopes f prime were the same from both sides of f. Yeah, and often one of those prerequisites works and the other one doesn't work. All right. Well, I hope this was useful and helpful, and I look forward to seeing you in our next review video, getting ready for the Chapter 4 test. Take care, everyone.